Good day, everyone. So, in today's class, we'll start right away with the very first concept from your syllabus, which is the function. And so, in order for you to clearly understand what is this function, how it works, what is its advantages, fine, we will be taking this very simple example here. And so, in this example, what we are doing is this is a calculator program. These are the list of coding that you'll be writing inside the program in order to perform the operation of a calculator. And in your this coding, what we have done is we have taken only one of four basic function of a calculator, which is addition, subtraction, division, and multiplication. Say, consider for example, in this program there are a total of 1000 number of lines. Remember this, when you are dealing with real life program, you will not be writing only 1000 lines. You will be writing more and more number of lines. So now what happened is, your interpreter, if you can recall from class 11, it will execute one line at a time, right? So it'll go to the first line and then proceed to the second line and the third line, the fourth line, the fifth line, so on and so forth till it reaches the 1000 lines. So if you use an interpreter here, writing this 1000 line program can be, it'll take lots and lots of time, lots of effort. And besides that, what happened is, in this program, so if a person need to perform only the subtraction operation, but what happens is you cannot ignore the addition, the division, and the multiplication. You'll have to write down all this, fine, whether it is needed or it's not needed. You'll have to write it down, and your interpreter will have to interpret starting from this line followed by this, and then it'll come to the required function. So what happened when we have to write all the unnecessary function, all the necessary unnecessary coding, what is not required? This becomes too time consuming. It'll take too much of time, right? We are writing all the things that that is not even required. Okay, that is one thing. Besides that, what happened is there will be so many loops here. Addition operation, you have loop for subtraction, you will have loop for division operation, you have loop for that, you have loop to again redo the program over and over again. So when you have too many loops inside a program, your program can become very, very, very complicated. Right? Okay. Besides that, now addition operations say I want to perform. I have written it somewhere here in the beginning. Fine. So I'll do this. Okay, done. Now suppose after multiplication or after division, I want to add the two number again. What do I need to do is, I will have to again write the addition operation one more time here. So every time I want to add any two number, I will have to rewrite the same program over and over again. So what happened here is, the same coding will be repeatedly written over and over again. There will be repetition of the program. Okay, so these are few of the disadvantage of why we normally don't want to write a very large program. Rather than having a very large program, what we do is we will try to break it down into smaller program. It's like when a task is assigned to you, find a very large task. What happens is, rather than you doing the task alone, you might want to divide the task and then distribute it with your friends. When you distribute a large task into smaller tasks, what happens is, when you divide it becomes less complicated. Yes or no? Fine. So here what I've done is, I've taken the same example of addition, subtraction, division, and multiplication. Now the difference between the previous program and this one is that I have divided this program into smaller program, where I'll be writing a separate code for addition in a separate program, separate code for subtraction, separate code for division, likewise a separate code for multiplication. So all the addition operation will be written here specifically, subtraction here, and so on. So these are smaller unit independent unit, fine, and they are designed to carry out some very specific tasks. Addition is designed only to perform the addition operation. Subtraction only to subtract numbers, only to divide numbers, and only to multiply numbers. Now these are four independent units. Now since they are independent unit, what we have to do is we have to find out some means, right, to connect them with each other. Fine, we have to wrap them inside the same software. Now this software that we'll be writing down, we will call this as the calculator software. Now this calculator acts as what we call as the main program. This is the one that will actually connect all the sub functions here, the addition, the subtraction, the division, and the multiplication operation. Now every time say user want to add any two number, what your calculator will do is, calculator will send a request to the addition operation, ask this to add up the number required. This one will add up the number and the answer will be forwarded back to the calculator. If a calculator need to divide any two number, it will send a request to this particular unit. This unit will divide the number and the final answer will be sent back to the calculator. In this case, what happens is, unless a user want to subtract a number, this will not be interpreted by the interpreter. Unless the user want to multiply any number, your calculator will not connect this. That means your interpreter will not interpret any of the lines that has been written inside this coding. Fine. So this subdivision that we have here are referred to as the sub-programs or the sub-functions. And there's a smaller program that we have written down. This here is called as the main program, like what I have already mentioned. So now your main program together with the sub-program or the function here is referred to as a program. So this here comprises of one program, and this particular program that we have here can be referred to as a calculator program or a calculator software. Fine. So breaking down a large program into smaller independent unit to carry out a very specific task. They will be connected with each other with the help of a calculator. Now, the advantage of dividing a large program into a smaller program is because of this. Your program becomes easily manageable. You'll be able to manage it easily. Fine. You don't have to refer to all the coding, but you'll refer to only those very specific coding that is required. It'll take less time for the interpreter to interpret it. Only the required function will be interpreted, whereas the rest which is not needed, your interpreter will ignore that. It becomes less complex. Fine. You will not have so many for loop. There won't be too many connection between each and every function. And then most importantly, you will avoid repetition. There will be only one function, and every time your calculator needs to perform say the addition operation, it will be calling the same function over and over again. Like in the previous example, you will have to write say addition 3 times if you need it 3 times. In this case, we'll write it only one time, but we will be calling it over and over again. Okay, what is more important is your function here are designed to carry out some very specific task operation. Fine. Like in case of your addition will carry out only specifically the addition operation, adding of numbers. It can be 2 number, 3 number, 4 number, and so on. But it will be designed only to carry out those very specific tasks. Fine. So this here what we have can be referred to as the properties of a program. There are a few more. You can always add up more here. But these are 5 of the basic properties of writing a function, or you can also call it as advantages of writing a function. Now, regarding the definition, I'm leaving this as an assignment to you, and I want this assignment to be submitted by the end of today. You can submit it later in the night, but I want it by the end of today.